So thanks for making it to this late hour talk. So today we're asking if unsupervised machine learning can be overfitted. And obviously the answer is yes. Otherwise I could fly home. And this is what we're going to be covering today. So first of all, we'll explain a bit about supervised versus unsupervised ML, as I'm going to be talking about the unsupervised setting. And then we're going to take an example of an actual data set, a public data set of Alexa customer reviews, and just sort of overfit it by mistake. And we're going to see together how it happens and what we can do about it. All right. So just a quick recap about supervised versus unsupervised. So in the more maybe classic supervised setting, this is on the left, you can see a classification example of where I want to classify images to duck and not duck. And a person has kindly annotated my data set for me, my training set. Each image is marked duck or not duck. And I'm using that information to build a predictive model to tell the difference between duck and not duck. And then when I deploy this model to production, I introduce it with a new image and I ask it whether it's a duck or not. So we're not going to be talking about supervised ML at all today. We're going to talk about unsupervised. So on the right, you can see an example of different animal images where I don't have any ground truth for it. So no one has annotated it. I don't know anything about those images, but still I want to draw some insight from them. In this case, I want to cluster them. That means that I want to group together similar images of similar animals and for different animals to be grouped separately. So still I want to draw some insight, and that's pretty cool, this use case. All right, so I want to define overfitting in a supervised setting because that's the more classic use case that we usually encounter. So we want to classify each point here, each dot, to be blue or red. So this is a classification problem. And as you can see, when I'm underfitting, I'm fitting a model that's too simplistic, right? So this straight line is too simplistic, so it's missing some of the distinction between blue and red. And when I'm overfitting, I'm learning the data points too closely, as you can see in this plot. I'm learning all the details of my training set without taking into account that this is just a sample. And in production, the data set is going to look a bit different, right? So there are going to be red points here, and I will miss those. So that's overfitting in the classical supervised setting. And why am I talking about it? Because that's the more classic context where supervised machine learning, where overfitting is mentioned. And for the unsupervised, it's really not mentioned in our community so often. And it's kind of almost disregarded that we can overfit in unsupervised. So if you can look back at the duck picture, it's sort of at first glance unclear how I can overfit if no one is telling me what the ground truth is. So how will I get to this situation? So we'll see in a second. All right, so now it's a perfect time to introduce myself. So my name is Dana, and I'm a machine learning team lead at a company called Pendo in Israel, if you could tell by my accent. And the reason that I'm giving this talk is because at work we have been dealing with a similar problem over the past months, where we're taking customer feedback reviews and trying to extract some themes from them, to do some topic modeling. And this is a classical unsupervised learning situation, right? Because someone is giving me a bunch of text and I need to sort of figure out what this text is talking about. And the use case we're going to cover together, it's pretty similar to what we're doing at Pendo right now, at machine learning at Pendo. We're going to be looking at Alexa customer reviews. So this is a public data set. You can find it at Kaggle. And it's a data set of thousands of customer reviews. It's just people that have reviewed Alexa products, and they're saying, what they like or dislike about the product, customer reviews. So for example, they're saying it's easy to set up and use, and so on. This is a sample of the data set. So imagine that you're an end user that you want to buy some product, Alexa product, and you go on a site and you see like thousands of reviews. So now you have to manually read them and sort of try to figure out what are the good features of the Alexa products and what people are satisfied with and what they're dissatisfied with. So that's like crummy manual work that we want to avoid. Instead, we want to facilitate we want to build a model to extract the themes, to tell you in like a high level setting that these are the main stuff that people are happy with, and these are the problems with this product without you having to read through all the reviews. So this is the model we're going to develop. We're going to develop a theme extraction over this data set only for positive reviews, just to make it simple for us. And the one more important thing is that we need to actually capture a business meaning. It will become clear in a second, but just imagine, like from a product point of view, if you're an end user and you're reading a review, you want it to make sense in your eyes. Like it's not enough that the theme will be correct, like in a machine learning sense. It has to bring value to you as an end user. You will see in a second when it doesn't, how it looks like. All right, so we're gonna be working with a simple model. It's much simpler than we usually build, just to make our lives easier to go through this example. So the first step, we're going to look at each review and extract the set of words that it consists of. So you can see superb sound is broken out down to the 1 gram superb and sound. And then we're just going to group together all the reviews that have a common word. So here you can see those 3 reviews. They're talking about sound. And then, finally, we're going to pick the largest clusters, let's say top 10 or top 20, to be our themes. So their common word is going to be the theme, and that's it. Pretty simple, pretty straightforward. So I've ran this model at home over a sample of 500 reviews, like the ones you saw before, and I want to show you what I got. So I'll give you a moment to look through this. Who thinks this is a good output? Great. Okay, so let's look at some reviews associated with each theme. So first one is love. Remember I said that it needs to capture a business meaning? That's an example of not capturing it, right? Because it's pretty sensible now that we think of the model we built that such words will pop up, because people are talking about stuff they love about Alexa products. So it's obvious that it's a common 1 gram, but it doesn't mean anything to you and me when we want to understand what the user is happy with. So that's a pretty bad, low quality theme. Great, it's the same, obviously. Echo. So Echo, it's one of the Alexa products. It's sort of a speaker. And it's also sensible that when people are reviewing it, they're mentioning the name of the product. Also doesn't have any business meaning, and it's not interesting for us as a theme. Alexa is the same. Here we go, silver lining, we have a good one. So people are talking about the fact that they like the fact that Alexa is playing the music they want to hear, and this is pretty good insight, right? We want to know about this. And downhill again, work. So it's just a common word, but doesn't indicate anything as well. So you can see there's a lot of sort of junk when I'm going through this list that I will in a second have to find a way to get rid of this junk, because this is not a good model that I want to deploy. Another good topic is easy to use. People are saying it's easy to set up, pretty insightful. And the last one that is high quality is the people discussing the sound, that the sound has good quality. All right, so 3 good themes, the rest of them are junk, and now we have to find a way to improve ourselves. So in machine learning, and in this case, what we do when we want to improve, we sort of look at where we were wrong and try to characterize it. So what we're going to do is going to ask a bunch of questions, a bunch of hypotheses, and try to sort of interrogate the data set to see which ones are correct and how we can improve our model. This should sort of ring a warning bell for you, because earlier I said that in overfitting, we're trying to fit the training set too closely. So be suspicious of what I'm doing and try to understand as we go what are the mistakes that I'm making. So let's see. I just gave a few examples of hypotheses to test, just to show you what I looked at home. All of this, by the way, is real. I didn't need to, I sort of only split my data set into bulks, and this happened without me trying to force it. It's that simple. So my first hypothesis is that maybe short text is sort of uninformative, because when people are saying, love it, great product, it's kind of hard to extract a signal from it. So I should really look into that and see if it makes my model better to filter that out. I also want to look at the low quality themes. What do they have in common? Also, I have a bunch of other ideas. Maybe I should drop the long reviews, because there's a lot of text there, and when I'm looking at each common word, it can create a lot of junk, right? And there are a bunch of hypotheses that we can try, and usually, you know, in machine learning, that's what happens, because people have all sorts of ideas, like they look at an input and they say, oh, I know why this is, it's because I didn't account for this or for that, and they start to investigate and have a lot of ideas of how to improve. Okay, be suspicious. So, this is what I found over the training set. You can see the words in pink. They're great, love, and like. These are very common words to find in positive reviews, and I should really just filter them out because they're inherently junk and they can't be good themes. I have a way to sort of bucket them all together. It's not a problem, and I'll just throw them away. Another group of bad themes are obviously product names. So that's very natural. I can just, I have a list of all the product names that people are reviewing. I'll just filter those out too, pretty easy. And the last one, it's more subtle, but it's true. You can see that the good themes are nouns and adjectives, and that makes a lot of sense, because a theme that's a noun is actually a theme that says what is the feature that I'm happy with, what's the object, and a theme that's an adjective is describing what quality I'm happy with, like easy. On the other hand, verbs, they're kind of not good candidates to be themes, because they're just the operation and not like the adjective or the noun. So I should just drop all the verbs and I'm good to go. All right, so this is our final model. We retained the former steps, just reduce each review to a set of words, and then filter out all the junk, right? The love words, the verbs, and the names of the product. Seems pretty sensible, and I think we're ready to ship. This is the output I'm getting over my training set, and it looks pretty high quality. So how many of you guys think that when I deploy to production, the next data set I'm going to encounter is going to produce good themes over it? Right? How many think that it's going to produce bad themes? Okay, great. We're in good shape. So this is what happens when I run it over a next batch from next week, let's say, of 500 reviews. This is what happens. So the emoji here is pretty much in shock, because you can see that easy music and sound, they pop up again, which makes sense because people are continuing to talk about it still, but a bunch of other junk has been introduced here in this list, right? So the nouns, I sort of assume that nouns have to make good themes, and that's not right. So thing is obviously a noun, and it doesn't mean anything. It's not a good theme. And so do device and product. I don't want to see those themes. Obviously, people are reviewing the device, so they're mentioning it, but they're nouns and they make bad themes. So one of my assumptions was wrong, and I tested it over the training set. It was right, but in production, it's not right. All right. This is kind of cool. We have 2 new themes that we haven't seen in the training set, which is kind of the point. And this is one of the benefits of unsupervised machine learning. When I run it on a new batch of dataset, I get brand new results. And if I were to be in the supervised setting, then I would have predefined the themes or the categories, so new themes would not have popped up. So this way, I'm getting this benefit, which is cool. People this week are saying that the speaker has good quality, and it's also cool that it can switch the lights on and off. So I think that's nice. And one other thing that I missed is, again, my assumptions that verbs make bad themes. So setup is something I would have gotten if I hadn't filtered out the verbs. People are saying that it's easy to set up, and that's actually quite insightful, and it's a shame that I missed it. All right, so I guess that maybe some of you understand how we got into this situation and how we overfitted, but let's circle back into the definition again and really explain what we did wrong. All right, so overfitting has a bunch of different definitions, but I like this one, the following one, that talks about noise. So when I sample a finite sized data set, which is always the case, it's always finite, it inherently has some noise. And when I try to fit this training set too closely, I just, by mistake, learn the noise instead of the signal, and I lose my ability to generalize. So that's kind of what I did before, right? I tried to look for explanation for each bad theme that I saw in the training set without taking into account that when I draw a new data set, not all of these signal will be there again. I mean, like with the verbs and so on. And, you know, this is sort of a definition for supervised, but I can reduce it to a more generic concept that's always true, even if I don't apply it to machine learning, just to statistics. And the principle is that when I have a finite size data set, which is always true, it's always finite, I never get everyone when I sample, I can only ask a finite number of questions before it starts to lie to me. So I have to be careful about how much I ask before I start getting some wrong answers. So that's sort of a basic principle. And I want to give you an example that's not even from machine learning, but it really, I think, makes us internalize what this is about, what overfitting is about. Because, you know, it pops up a lot in different scenarios, and sometimes we miss it because we don't realize that this is what's happening. So let's say I want to go to the office today, and I'm worried that I may have COVID, so I take an antigen test. All right, it's negative. I'm not happy. I'm kind of, neurotic, and I know that the COVID test, it can be false positive or false negative. So I better take another one. So I do that. Still not happy. I take another one, and another one, and another one, until one is positive. Funny story, I wrote these slides like a month ago, and then last week this happened to my sister. So she took like 10 tests, I swear, and one of them suddenly came out positive. So she called me to say, listen, I'm sick. I can't make it to our coffee date. And then she went and got a PCR, which was negative. So what mistake did I make here when I believed this positive test? First of all, I just took more and more tests until one of them showed me what I wanted to hear, which is what we did before when we looked for why the explanation for the crappy themes, right? Because we just tried more and more hypotheses until one of them turned out to explain the variance in this specific data set to our satisfaction. So I just took more and more tests until one was wrong, and eventually one will be wrong. And secondly, I believed the last one. So I just disregarded the fact that a bunch of them was negative. Once I saw positive results, I was like, okay, I'm sick. Okay, so how does this tie back to what we saw? What did we do wrong in this example of the Alexa customer reviews? First of all, this is kind of basic. In supervised learning, it would never happen, but in unsupervised, it's common. So I didn't test my model on an independent test set. So it never saw any data set other than the training set. And I sort of made the mistake of believing the accuracy of this training set, which was overfitted. So that's one thing I did. The second thing is that I tried to explain 100% of the bad themes. So I tried to get 100% accurate results, which is really the recipe of how to overfit, to explain exactly what we're seeing in a training set. And third, and this is more subtle, but it's a common mistake, I tested a very, very specific and granular hypothesis, which is a bad idea. Usually, we try to test a bunch of simple hypotheses because the more complicated my question is, it's based on more assumptions, and one of them can be not correct. All right, so let's look at the upside. We have a bunch of ways to sort of reduce the risk for overfit, and these are the tips that I have for you. First of all, measure yourself. When you're done training, take a test set that your unsupervised model hasn't seen before and run your model over it and measure it and see how it really does. And that way, you won't get the shocked emoji when it hits production and suddenly the performance is bad. Just be careful not to iterate over that one too, because if you do, it will be overfitted too, if you continue to train and then measure on the test set. Second thing is don't iterate too much on the training, because as we said, you will get a positive COVID test eventually. So what we try to do usually is like define in advance a few simple solutions to test, and not just and not then after we see the results, examine the data and sift through it and try more stuff and so on. Just try not to iterate. And finally, just keep it simple. So test simple models, not complicated models, and make simple assumptions on your data. So I hope I've convinced you today that overfitting in unsupervised setting is a real issue, which can cause production problems, and that there's really a good way to mitigate it as long as we follow the rules. Thank you.
Thank you very much, Dana. We have a couple of questions here.
Sure.
The first one says, which kind of model did you use and why?
Is the person that asks it's here?
I'm guessing so, yes.
Okay. Is it too loud, by the way?
No, it's fine.
Just in my head, it sounds like. What model I'm using, like in production for our problem?
So I think the question is specific to the
okay.
to the
So
presentation.
this is a model. It's kind of a big word for the algo that I used here. It's a simple algorithm, but I can tell you that when we really examine solutions, we can try a bunch of stuff. I can give a spoiler and say that right now we're testing a few solutions. LDA can be a solution for theme extraction. We're actually testing deep learning as well. And I found that sometimes just doing some simple algorithms and adding more steps to them, it can solve a lot of problems without being too complicated. For example, may I expand for 1 minute? Sure. Okay. For example, all the words that I showed you that we produced a set of words from a response, there's really a lot of methods to reduce the dimension of this bag of words because it's like a serious amount of words. But I can do a lot of normalization, right? So I can stem them, I can lemmatize, I can find similarities with embeddings, so I can really reduce the size of the problem so that after that, simple clustering may very well just extract high-quality themes. So I don't need to always go into the fanciest solutions to get a good model.
Thank you very much. Another question here. Interesting idea of generalizing the concept of overfitting to an heuristical approach to try to solve the problem. What was the initial objective and how do you guys measure its achievement?
All right, that's a really good question. So for our use case, what we want to see is that for each cluster, we have a good precision. Usually, it's 80% and above in terms of user experience. It's considered pretty good because it means that out of 10 responses that I say are related to sound, 2 are not related. So it's a pretty decent user experience. And another important metric, it's coverage, right? Because if I optimize to precision too much, I miss a lot of themes that I could have caught. So it's kind of a fine balance.
Okay, thank you. What about using negative reviews to exclude common words?
Yeah, okay. So I just concentrated on the positive reviews here just to keep it simple. Sorry, could you repeat the question?
Okay,
I forgot.
So the question is, what about using negative reviews to exclude common words?
Yeah, okay, good question. So what we do usually, we define the business problem. In this case, I just reduce it to positive reviews, as I said. But in production, in my case, we want to extract the signal both for negative and positive. And in the EDA, EDA, exploratory data analysis, when we sort of explore the training set to see what it's made of, the first thing we explore is if we have a problem with sentiment. What do I mean? If most of the time people that are scoring positive reviews have a positive sentiment, then I don't need to worry about negative words, which in my use case that I'm working on, this is the case. So it's really unnecessary to deploy sentiment or exclude negative words and so on. And really, I do believe that start with the naive approach. That's the best way to go. Because that way you are not solving a problem that you don't have, thus investing resources and time and so on to solve problems that you may not have. And in addition, if you release some baseline model that performs well, it has to pass some criteria, but it performs well, and then you introduce the improvement, you can measure it like each delta, you can measure it separately, and it's more controlled that way.
Okay, another interesting question here. Did you try the same approach with most advanced NLP models, such as BERT? Keywords-based models are known to have those kind of overfitting effects.
Yeah, I agree. Yeah, we're actually testing it right now. So it's supposed to go to quality checks next week, actually. Yeah, looks pretty promising. BERT topic, that's the one we're testing. Yeah, looks really good.
Okay, and the last question here. Have you also considered semi-supervised learning approach?
Not for this case. For this case, we don't really have any annotation, and no, not for this case.
Okay, do we have questions in the crowd? Okay.
Yeah.
Couldn't the business meaning of word be considered an annotation? Because in the end, the human is looking at a word and saying this is business relevant or not.
Yeah, you're saying if we, I repeat the question. He's asking, couldn't the business meaning of a word, like if a person were to indicate for each theme or each token, if it has business meaning or not, could it help me? If that will be definitely. You know what I call that? Roadmap. Definitely. Mm-hmm.
Any other question for our speaker? Okay, thank you very much, Dana.
Thank you, everyone.